Section 2.7, Functions and Mathematical Models. This is the last section that we will be covering in Chapter 2. We will not be looking at Section 2.8. So, functions, first part of this section I want you to be familiar with. You need to understand what a rational function is. Okay, so we talked about this already, but just know, for example, if you see something like this, this is an example of a rational function. It's just a quotient, right? It's just what? A polynomial function in the numerator divided by another polynomial function in the denominator. So if you see something like this pop up, just make sure you know that it is a rational function. Be able to name the function. Power function looks like this. So an example of a power function might be, let's say, g of x is equal to x to the 2/3. That's an example of a power function. Again, just be able to identify that this is a power function. The next part of section 2.7 I want you to be familiar with is how to come up with mathematical models based on given information. So ultimately, we will be solving application problems. But, what we really want to be able to do before we can solve anything is set them up. That's usually the most difficult part. So here are some guidelines for constructing mathematical models. Feel free to look at that, pause the video, take notes, and then I'll be going over a couple of examples with you. Okay, let's take a look at our first example. Enclosing an area. Patricia wishes to have a rectangular garden in her backyard. She has 80 feet of fencing with which to enclose her garden. Letting x denote the width of the garden, find a function f in the variable x, giving the area of the garden, and then what is its domain? Okay, so first thing is we're going to let x be equal to the width of the garden. All right, so let's see what our picture would look like here. We have a rectangular garden of some sort. X is the width. We have no idea what the length is. Let's just make y. Let's let y be equal to the length of our garden, okay? All right, so we know that the perimeter of this particular garden would be what? Well, it's all four sides added together, right? So the perimeter of our garden is going to be 2x plus 2y. And we know what the perimeter is because it gives us that in the question. She has 80 feet of fencing. That's a linear unit right there, okay? So that's the distance around this whole thing, 80 feet. So P, perimeter, is going to be 80, okay? So now we have an equation which we're going to be able to use here in just a moment. Let's see. Find a function f in the variable x, giving the area, okay, of the garden. So we don't have area yet, but we can figure it out, right? Area is the same as what? Well, area is length times width, so y times x or x times y. Now, our goal is to come up with a function f in the variable x. So a is going to become f of x, and we need this function to be all in terms of x. Well, right now we have it in terms of what? X, y, right? We have area as a function f in terms of x, y. So what we need to do is come up with, we need to come up with an expression in terms of x that this y is equal to. Oh, how do we do that? Look back at your perimeter model. So based upon knowing this equation, we could now do what? We could isolate the y variable. So that's your goal, okay? You're going to have some situations like this where you're given one equation, maybe perimeter, whatever it is, and then you're asked to figure out some other, some other type of unit. So this will be like perimeter, distance around, but we're actually trying to figure out the area. So that's a square measurement, square unit. So you have to use the perimeter equation in order to come up with that function. And how do we do it? Well, we have to solve for y. That's what we need. We need y in terms of x. So let's divide everything by 2. If we divide everything by 2, we have now y isolated. So what we're going to do is we're going to take what y must be equal to in terms of x and plug it in right there for this y. All right, so in other words, you get f of x is equal to x times whatever y is equal to. And y is equal to what? 40 minus x. So this is the function f in the variable x giving the area of the garden, okay? Now, of course, if you want to, you could multiply the x through, and you'd get what? 40x minus x squared, all right? Okay, but with that being said, this portion right here, this form of our area function is actually going to allow us to come up with the domain of the function. That's the next piece of the puzzle here. Okay, so in the factored form, remember, okay, first of all, this only can occur in quadrant 1, all right? X can only be non-negative, all right? And therefore, y can also only be non-negative. So understand that. So to come up with a domain, what's the first value that x could be equal to? Well, really, it could be equal to anything greater than 0, right? Or it could be equal to anything less than what? Less than 40. So what you're going to do to figure out the domain is this. To figure out the domain, you're going to let each factor be equal to 0, and then you're going to solve for x. You're going to let each factor, in the factored form of the area function, f of x, each of those factors has to be equal to 0. So we get x equals 0, or what? X equals 40 if you solve this, right? 40 minus 40 is clearly 0. So what's confusing, though, what's confusing about this is that the values that have to make up the domain are going to be inside of these brackets, all right? Which may be a little illogical to you, because if x is 0, then this thing doesn't, I mean, there's no area, right? And also, if it's 40, there's also no area, right? Well, that's okay, though, based on a theory we're going to learn in calculus, all right? You have to have a definitive starting point. That's why it's inclusive. And a definitive ending point. That's also why a bracket is used here, inclusive, in order to define the domain of this, so that when you want to maximize it, you can apply the absolute, an absolute value theorem here to allow us to accomplish that goal. All right. Bottom line is use brackets. You got to use brackets so that you have a definitive starting point and ending point.